All right, today we're going to be talking about systems of equations. And today we're going to be solving them by graphing. Later on next week we will go ahead and solve them algebraically, but this week is all about graphing them in different types. So we're going to be solving systems of equations by using tables and graphs, mostly just graphs. And we're going to classify them under the different systems. All right, so what kind do we have? There are the three names up here: consistent and independent, consistent and dependent, and inconsistent. We really don't use those very much. They are there. You could always refer to them that way. Basically, we refer to this bottom one as intersecting, this one as the same line, and then this one as parallel. So when we have two graphs, we can either have them intersect, and when they intersect, they have one solution, and we need to know what that solution is. We want to know that one spot where they match up. Okay, in this case, it may be like -1, 0. When it's the same line, we just say that there's an infinite number of solutions because they match up over everything. Every spot on this line is a matchup with the other line, which is actually the same line. That is possible. And then the parallel lines, we know what parallel lines are. They never intersect. So where do they match up? They never do, so it's no solution. So those are the three possibilities. We can have one solution, many solutions, or no solutions. So those are the three different characteristics or classifications that we can go ahead and have. All right, so you'll need to make sure that you watch the video of how to go ahead and do these on the graphing calculator. But I'm just going to go through a couple problems just so you can kind of get an idea. So we have this equation here. Now there's two of them that are in standard form. We, of course, do not like them in standard form. They don't go into our calculator very well. So we need to go ahead and change those. So we're going to put them into y equals. So for the first one, we're just going to move the x over, so -x plus 3. And for the second one, we're going to have to move the 2x over, and so it's going to be positive 2x when we move to the other side. Still the -6, so -6. Then we will go ahead and graph it. And we're looking for that point of intersection, and it's right here at 3, 0. So the solution is 3, 0. This is definitely an intersecting line, so when it does intersect, we need that point that they intersect. Let's try another one. So here we have x plus y equals 2, x minus 3y equals -6. Now we're going to have to solve this. We're going to have to move that x over, so it's going to be y equals -x plus 2. And this one here, we're going to have to move the x over and then divide by -3. See that -3? So we're going to get a -1/3 x. Actually a positive. By the time we move that over, it's negative, and then another negative is positive. So it's 1/3 x plus 2. And so you got to make both of those y equals. Again, this one's going to be a little more difficult because you have to divide by -3. But then we graph them both, and there is an intersection point right there. Again, you can use your calculators and go into second trace and find the intersection point there. But it is 0, 2. Here's another one. Again, these are going to have to be solved. So we're going to write them in slope-intercept form. So this first one, we're going to move the x over and then divide by -2. 0 divided by -2 is obviously still just plus 0, so I didn't even write that in. So it's 1/2 x. And the other one is really easy. That's just -x plus 6. Got to graph them both and tell me where they intersect. And this one intersects at 4, 2. All right, what about these two? Again, there's a matter of going ahead and moving them over and graphing them. When you do that, you should get a 4, 1. Now remember what I said, sometimes they're going to be more than just intersecting. There's two other possibilities. There's a no solution, which is parallel lines, or there's the same line. So when we go ahead and we start taking these equations and we start solving them for y, we're going to put them in slope-intercept form. In the first one, we get y equals 3/2 x plus 1. Move the 9 over and divide by -6, reduce it to 3/2. And we do the same for the second one. Notice these two equations. What do we notice about them? They are exactly the same. When they are solved for y, and they end up being exactly the same, this is the same line. This is the infinite number of solutions. So when I graph it, it only looks like it's one graph because they graph on top of each other. And so we will go ahead and say that this one has an infinite number of solutions. So there are infinite many solutions. Let's try the other one, the parallel ones. And we're going to solve these for y equals. So move the 15 over, divide by 6. and y equals 5/2 x. Again, the plus 0 if you want. And here 5/2 x minus 5. And notice how this one works out. They're not the same, but they have the same slope. Remember, parallel lines have to have the same slope. We learned that last chapter. And so we're going to go ahead and take a look at these two. And when we graph them, they end up parallel. They have just different starting points. This one starts at 0, this one starts down here at 5. But they all go up and over the same amount. And so they never intersect. So that's parallel lines are no solution. And that's what I have for you today.